Hello everyone. This video is going to talk a little bit about the kinds of groups that we identify on a phylogeny and how ideally we'd like to match up phylogenies with the names that we give organisms. So let's delve into that a little bit. Normally we want to deal in monophyletic groups. A monophyletic group is a group that includes the most recent common ancestor and all of the descendant groups. So to be a true monophyletic group, we can't exclude any of the groups that have descended from that common ancestor. So let's have a look. Here is a monophyletic group, right? This is just the tip clade, and we're incorporating its ancestors since the last time that it split from another taxon. But this too could be a monophyletic group. Now maybe it's bigger. Maybe this is the species and the last one is a population. Maybe this smaller group is a species and this is the family. Remember that we can nest those groups within one another. But both of those represent monophyletic groups. And if we think about it, so too does this entire phylogeny, because it shares a most recent common ancestor, and it identifies all of the descendants of that most recent common ancestor. What we want to avoid when we're naming groups is that we want to avoid things like paraphyletic and polyphyletic groups. Paraphyletic groups include the most recent common ancestor, but they exclude one or more descendant taxa. So that most recent common ancestor is included, some of the descendants are included, but some are excluded. Let's have a look at what that looks like. So if we identified all of these in the shaded here as part of whatever group we're looking at, and I'll give you examples in a minute, but we excluded that one branch, that would make this group paraphyletic. That's a problem because it doesn't communicate clearly all of the members of that group. So we could reformulate that and we could exclude this whole polytomy at the bottom. Right? And so this second shaded area is also paraphyletic. It includes the most recent common ancestor, and in fact you can see that right here. And it includes some of those ancestors. It excludes the polytomy at the bottom. So it excludes those three taxa. And that's a problem. I mentioned a moment ago that the other problem we want to avoid is polyphyletic groups. Polyphyletic groups exclude the most recent common ancestor and may exclude descendant taxa. Although, in theory, I guess you could include all the descendant taxa and just exclude the ancestor. But generally we see a polyphyletic group dropping the most recent common ancestor and some of the descendants. What does that look like? Well, if we got all three of these groups in the polytomy and just one from the clade at the top, that would make a polyphyletic group by excluding the most recent common ancestor of the two branches. We also happen to exclude some of these descendant taxa. So these are the way that we might compare those groups. Hopefully you can sort of see the differences visually, because that's a really important thing as we're trying to name organisms and as we're trying to maintain high quality biological names. Let's have a look at some examples. So some of these groups are probably familiar to you, some may not be. That's okay. I'm looking more for the taxa as we discuss this. So the birds are at the top, crocodiles and their relatives next, etc. You can see the mammals these three groups in the middle are often are identified as reptiles. But current evidence suggests that the aves, the birds, are not a member of the reptiles. They aren't consistent with the reptiles. We generally study them separately from the reptiles. But current evidence places them as a descendant of the same common ancestor as reptile groups. And in this phylogeny, the same common ancestor as the crocodiles, which would be described as reptiles. Let's have a look at another example. So these are all familiar names. There are three separate dinosaur taxa that break off here, and you can probably already see the problem. I'll give you a minute to look at this. The problem is the dinosaurs. So birds are believed to have descended from a dinosaur ancestor. So putting dinosaurs as part of a group and excluding the birds makes a paraphyletic group. So we've got the most recent common ancestor of the group, and if we look, that's right here. But we're excluding one of the descendants, that is the birds. Again, that's a problem. It doesn't clearly describe the group. One solution that's been proposed is that the Dinosauria could represent the entire dinosaurs and their descendants, that is the birds. So that the Dinosauria would make the dinosaur and bird clade together monophyletic. But by itself, the dinosaur clade is paraphyletic. Let's have a look at another one, a little bit more complicated. I like this because we can actually map some real taxa onto this. So this is in the order Hymenoptera. So Hymenoptera are a group of social insects, generally social insects, and within that group here are several families. And you don't need to worry about the scientific family names here. Instead, what I want you to focus on are the wasps. So at the top we have sawflies. Next we have a parasitoid wasp group. Then we have wasps and hornets, ants, digger wasps, bees, cuckoo and jewel wasps, and chelicids, solitary wasps. So this is the order Hymenoptera, and it shows several of the families. And the problem is that when we talk about wasps, we talk about a large number of these groups, but not all of them. We exclude the sawflies, and that's fine. They're an outgroup. They're not part of the clade. But we would include the most recent common ancestor while excluding the ants and excluding the bees. That's a problem, because now those are groups that have descended from the same common ancestor but are not allowed to be part of that group. So the only way to make this a monophyletic group is to include ants and bees in the wasps. Let's take another look. So that was another paraphyletic group. Let's pick out the marine mammals from this phylogeny of the mammals. All right, so what's going on here? Well, here are the marine mammals. It excludes their terrestrial ancestors, presumably terrestrial ancestors, and remember that these are hypotheses. But there's older versions of the hypothesis behind the mammal group suggested that the marine mammals were a single group. If we continue based on current evidence to make those marine mammals a single group, it becomes polyphyletic. Because at this point there's evidence that mammals reinvaded the water more than once. So a common ancestor of the cow and the dolphin invaded the water, and that's what led to the dolphins of today. A common ancestor of the dog and the walrus invaded the water and then evolved into the walrus. Likewise, a shared common ancestor between the elephants and the manatees entered water, and some of them stayed on land. Those eventually give rise to our modern elephants. Some move into the water. Those give rise to our modern manatees. So this is a polyphyletic situation because we exclude the most recent common ancestor. So let me wind up just a little bit here. I've shown you some bad taxa. That doesn't mean that there aren't good taxa out there. There are plenty of good taxa. Currently, for example, we believe that the mammals in general are a good taxon. So, a couple of concluding remarks. Ideally, we want taxonomic names to match data that identifies real groupings. When we name something, we want that something to be a monophyletic taxon. When the nomenclature, the names, don't match the classification, that is the groupings, then we wind up having bad taxa, like some of what I've shown you. Wasps, marine mammals, and so on. So those we can identify the specific mistakes. Are they paraphyletic? Are they polyphyletic? Ultimately, our goal is to have good taxonomy, good groups that match what we know about the history of that organism. So taxonomy aims to match empirically supported groups to correctly formulated names. We want our names to match what we believe the relatedness is amongst groups. So I hope that explains how we make groupings, why some groups are better than others, why some names are better than others, and why it's important for us to avoid some of those mistakes. Thanks for listening. Have a great day.